Alright, y'all, this is syscalls project 1. Let's get right into it. We're creating a system-wide process log level attribute. After that, we're implementing system calls to get, set, and log messages according to that attribute. We're going to make a library to invoke these system calls in user space, and we're going to test these functions and also build harness functions to test them for TAs and everyone. So, the kernel-wide process log level attribute. Following the resources, specifically the ones provided to this project, I saw that syscalls are implemented basically in two files. You are declaring them in syscall 64.table within this file path. It's kind of like the declaration. You do the number, you're setting the number basically, and providing the name for that function. But you're actually implementing that system call in kernel sys.c. So let me just show you what mine looked like. In the table, I set the number, name the function, and then you have this declaration in front of them, which I found all of them to have. This is the 64 register architecture specifications of the syscalls, and there's the 32 ones. I added mine, obviously, where the 64 are. Afterwards, in kernel sys.c, I noticed that's where all the other syscalls are defined. They're defined with these numbers that specify the amount of parameters that that function will take. For example, in the get one, I specify 0, so it's not going to take any. And so since all of these need to access the process log level, I initialized it here, which is within the kernel. So process log level gets initialized to 0, and then I get it, I return it, I basically check if it's root, if the current process is root. This was defined within the sim function, the same file. I check if the level is valid, and then I return correct. To log the message, if it's correct, if it's valid, we continue. If not, we fail. We define the log names that we want based on the log levels from 0 to 8. We call it process whatever. If we are able to log it, if the level is lower than the process log level or equal to it, we switch depending on the level, and the debug level, the debug messages are created like this with the case structure. Log names grabbed from the level, the executable name, the current PID, and the message. That's basically it. We rebuild, we reboot, and then we test them in user space, which we define here in a process log directory. I have a makefile, the process log.c, but I'm going to make it real quick and run it for you guys. I already pre-compiled these for the library, but since we just ran the library, it should work. Read it, harn. Fail, it does. Just succeed, it does. Just succeed, it does. Cool. And that's the harness one. Should be the same for the live one. And there we go. I'm gonna meanwhile talk about the process log.c. We define all the functions in the header file, as well as the sysget, set, and process log. Here we are. We basically just call them. That's all these functions should do. We just call the syscalls, pass the parameters in, and then the harness function is pretty easy. We allocate a 4-element array based on the set number or the get number or the process number. We add that to the first entry, number of parameters, return the level, and that's basically it. That is everything. Make sure you rebuild and then you reboot when you're testing. I did that also on a fresh VM. Nothing too crazy here. Initial testing was done in the test.c file to check for edge cases, but I basically ran all the set level, get level, set log level tests,